What if I told you that a great, invisible force is reshaping the Earth, and no one can stop it? It originates in the depths of the Pacific Ocean, but its footprint is everywhere. Floods, fires, crop failures, and even wars. By 2026, this force will return. La Niña is back. This time, the consequences could be extremely severe, surpassing any climate pattern we have seen before. This is not just weather. It is a fragile, living, breathing system, intricately connected to the scorching African deserts and the icy Antarctic coasts, woven together by invisible threads of wind, heat, and ocean currents. However, sometimes these invisible threads tighten and twist, becoming something entirely different. When they change, we see the signs: flash floods, mega droughts, coral reef bleaching, crop failures, and storms that seem to appear out of nowhere. These are not random events, but part of Earth's powerful rhythm, the El Niño Southern Oscillation, ENSO. You may have heard of El Niño, but its colder sibling, La Niña, is often more destructive. Today, we will focus on the La Niña of 2026, which could bring a series of events we are not yet prepared to face. We will explore what La Niña is, how it works, how it has shaped history, and its impact on the planet in the coming year. Let's begin. ENSO encapsulates one of the most powerful climate forces on Earth. The El Niño Southern Oscillation is not a single event, but a natural cycle that swings between extremes, a pendulum of climate chaos. It starts in the heart of the Pacific, born from a tug-of-war between ocean temperatures and atmospheric pressure. The ENSO phenomenon is the result of this interplay. This cycle has two main phases: the warm phase, El Niño, and the cold phase, La Niña. In between, there is what scientists call a neutral condition, a state of relative balance. But this balance never lasts long. When ocean temperatures rise and trade winds weaken, El Niño emerges. When the trade winds strengthen and cold water rises to the surface, La Niña rises. This is why it is more than just a weather pattern. The ENSO phenomenon doesn't just affect the Pacific. It reshapes rainfall, winds, storm tracks, and temperatures globally, from the Americas to Asia, from the Indian Ocean to the Atlantic. This is not speculation. It is history. We find the ENSO signal buried in coral reefs, locked in tree rings, and preserved in ancient sediments. Some of these records date back more than 10,000 years, showing that this cycle was influencing the Earth's climate long before the first cities were built. Now, it is beginning to swing again. In 2023 and 2024, a strong El Niño swept across the Pacific, triggering ocean heat waves and disrupting weather on multiple continents. Now, in 2026, La Niña is set to take the stage. How does this invisible force reach your skies from thousands of miles away, changing everything? To answer that, we need to look at the invisible engine behind it all. To truly understand La Niña, we need to look at the bigger picture. Imagine looking down at the Earth from the International Space Station, not as a puzzle of borders and cities, but as an interconnected system running on sunlight, air, and water. At the heart of this system is something simple yet profound. The sun does not heat the Earth evenly. Because the Earth is a sphere, the equatorial regions receive more direct sunlight than the poles. This energy imbalance gives rise to a massive flow of air, the Hadley circulation. At the equator, warm, moist air rises into the atmosphere. As it ascends, the air cools, and water vapor condenses into clouds, leading to rain. This is why tropical rainforests are found in equatorial regions. This air then moves away from the equator and eventually sinks in the subtropics, creating a continuous cycle. While the Hadley circulation moves air north and south, another important system, the Walker circulation, is at play, primarily affecting east-west air movement. The Walker circulation operates mainly over the Pacific Ocean, driven by trade winds. Near the equator, steady trade winds blow from east to west. These winds push warm surface water westward, where it piles up near Australia and Indonesia. This causes colder water to well up near South America, creating a vast heat balancing system. However, changes in the trade winds can disrupt this balance. If the winds weaken or reverse, warm water flows back to the east, triggering El Niño. But when the trade winds are stronger than usual, as is the case now, cool water surges across the Pacific and La Niña begins. This isn't just a local phenomenon. The changes in ocean heat and atmospheric pressure send signals across the globe, causing jet streams to warp, storms to change direction, and even entire seasonal patterns to be rewritten. In essence, the Walker circulation is like the heartbeat of the El Niño Southern Oscillation, ENSO, controlling the subtle shifts in global climate. By 2026, the pulse of this invisible force will beat more intensely. How has this invisible engine affected the world before? And what clues can the past reveal about our future? Looking back at history, the answers are astonishing. La Niña and El Niño phenomena, seemingly modern discoveries, have in fact dictated the rise and fall of civilizations for thousands of years. In the mid-16th century, as Spanish conquistadors set foot in South America, a strong El Niño event arrived with them. Massive floods and total crop failures thoroughly destabilized the Inca Empire, greatly weakening its power. This made the Spanish conquest much easier than anticipated, as if nature itself had joined the invasion. Fast forward to 1789, a time of turmoil on the European continent. Due to weather patterns linked to ENSO, successive crop failures led to severe famine in France. Bread prices skyrocketed, social tensions escalated, and public resentment grew. A few months later, the French Revolution erupted. This might just be a coincidence, but various signs indicate that the influence of the El Niño Southern Oscillation phenomenon extends far beyond climate. Even in modern times, the ENSO phenomenon continues to leave a deep mark on the planet. In 1997, an exceptionally severe El Niño event swept the globe, causing up to $45 billion in damages. Indonesia was plunged into drought, while Central America suffered deadly mudslides. From 2020 to 2023, the Earth experienced one of the longest La Niña events on record. This triple dip event brought catastrophic floods to Pakistan, forcing over 30 million people from their homes. East Africa was plunged into a severe drought, triggering a regional food crisis. The Atlantic, meanwhile, saw an unusually active hurricane season. The ENSO phenomenon is like an invisible hand that has continuously shaped the trajectory of human society throughout history, reminding us that the power of nature is not to be underestimated. Now, a familiar pattern returns. Meteorological forecasts indicate that La Niña will return in 2026. But will it replicate the past, or will it usher in a completely new chapter of climate? The answer may lie in the changes of the future. As we delve deep into the vast and serene Pacific Ocean, searching for the core of the current climate event, some significant changes have already occurred. The winds are shifting, the sea is cooling, and the world is beginning to feel the effects. As early as the beginning of 2025, meteorologists issued warnings for months, and now, everyone's fears have been confirmed. La Niña has officially returned. At first, the signs were subtle. Sea surface temperatures off the coast of South America slowly dropped, and the equatorial trade winds quietly strengthened. However, by mid-2025, the situation was clear. This was not a minor anomaly, but the beginning of a high-intensity climate event. According to data from the U.S. National Oceanic and Atmospheric Administration, NOAA, and the World Meteorological Organization, WMO, we are experiencing one of the strongest cooling trends in the Pacific since 2010. Sea surface temperatures in the central and eastern Pacific have dropped more than 1.5 degrees Celsius below average. This is an unmistakable sign of an active and developing La Niña. Models predict that this La Niña event could last until 2026, or even longer. Its subsequent impacts deserve our close attention. But what does this actually mean? This is the first question we need to clarify. La Niña is not a storm. You won't see its eye or its name on the evening news, nor are there radar images of it. In reality, it is a slow, global climate anomaly, a silent shift of energy that can ripple through the entire climate system. And once it starts, it's almost impossible to stop. During a La Niña event, strong trade winds blow warm surface water westward toward Asia and Australia. This allows colder, deeper ocean water to rise off the coast of the Americas, a process known as upwelling. But La Niña's influence extends far beyond the ocean. It also changes global atmospheric pressure, cloud formation, and precipitation patterns, as if redrawing the world's weather map. Some regions will experience catastrophic rainfall, while others will be plunged into drought and famine. Storms may arrive earlier or strike entirely new places. Disasters like wildfires, hurricanes, crop failures, heat waves, and floods will follow. Worse still, all of this is happening on an already weakened planet. We are not entering this La Niña state from a neutral baseline, but after an extremely strong El Niño. The oceans still retain residual heat. Sea levels continue to rise. Glaciers are melting at a record pace, and the atmosphere is more humid than ever before. The latest data from NASA's Earth Observatory shows that the contrast between the cooling of the Eastern Pacific and the warming of the Western Pacific is at its most extreme level in over a decade. This east-west heat imbalance creates a steep gradient, strengthening the Walker circulation and throwing atmospheric circulation into chaos. Scientists are now facing a stark question. Just how much worse can the climate crisis triggered by La Niña get? We have already witnessed La Niña's power, but this time, it may lead us into uncharted territory. In the next chapter, we will delve into the specific impacts of La Niña on different regions, from the floods in Southeast Asia to the rampant droughts in the Americas and the Atlantic hurricanes that could threaten the lives of millions. What comes next might shock you. As the La Niña phenomenon makes its comeback, a pressing question emerges. What impact will it have on the world in 2026? The answer varies by region because La Niña's effects are distinctly different across the globe. It reshapes the entire planet's climate patterns, but its impact is unevenly distributed. Some places will be inundated with floods, while others will be scorched by drought. Let's start with North America. In the northern United States and Canada, La Niña events tend to bring colder than average winters and higher than average precipitation. Blizzards in the Rocky Mountains and the Great Lakes region may arrive earlier and be more intense. Snowstorms could sweep through the Midwest with unusual ferocity. But further south, the opposite is true. California, Texas, and much of the American Southwest are likely to experience warmer and drier weather. The La Niña-induced wildfires of 2020 and 2021 were closely linked to California's most severe wildfire seasons in history. Forests, dried out by drought, became highly flammable, and strong winds fueled the flames, consuming millions of acres of land. Now, in 2026, a similar situation is re-emerging, and local officials have already issued early warnings for the fire season. Meanwhile, across the Atlantic, something unusual is quietly happening. La Niña weakens the winds over the tropical Atlantic, creating perfect conditions for hurricane formation. In 2020, La Niña contributed to a record-breaking 30 named storms. Now, the U.S. National Oceanic and Atmospheric Administration, NOAA, has already predicted that the 2026 hurricane season will be above average. The Caribbean and the southeastern United States could face more frequent and more intense hurricanes. This means cities like New Orleans, Miami, and San Juan face a higher risk, and coastal infrastructure, already under immense pressure from sea level rise, may not be ready to cope. Next, let's turn our attention to Asia and Oceania. In Australia, La Niña has historically been associated with heavy rains and floods. The 2010 to 2011 La Niña event triggered floods in Brisbane, forcing tens of thousands of people to evacuate. In 2022, another La Niña event battered the East Coast for months, causing mudslides that destroyed entire rural towns. In 2026, Indonesia, the Philippines, and Thailand are expected to face heavy rainfall again, increasing the risk of landslides, crop loss, and infrastructure collapse, especially in vulnerable mountainous regions. Meanwhile, in East Asia, particularly southern China and Japan, weather patterns will become wetter. Monsoon rains could intensify, triggering floods and affecting food production throughout the Indian Ocean region. In East Africa, particularly Kenya, Ethiopia, and Somalia, a severe drought is likely, consistent with the La Niña pattern. From 2020 to 2022, East Africa suffered its worst drought in 40 years, with over 20 million people facing the threat of famine. Now, with another La Niña crisis looming, aid agencies are already preparing for water and food shortages. But in West Africa, the result could be the opposite. Stronger monsoon rains may return, which could boost crop yields in some areas, but also increase the risk of floods and cholera outbreaks as local sanitation systems may become overwhelmed. The situation in South America is also grim. Ironically, La Niña often causes one of the planet's most vital ecosystems, the Amazon rainforest, to dry out. The drought in the region not only leads to tree death, but also releases large amounts of carbon into the atmosphere, accelerating climate change. In 2021, a strong tropical cyclone coincided with the fire season, destroying over 5,000 square kilometers of rainforest. In 2026, such a disaster could happen again. In Argentina, Uruguay, and southern Brazil, La Niña has historically reduced rainfall during the critical planting season, which means potential agricultural losses, rising food prices, and economic pressure. Europe, though far from the Pacific, is not immune to La Niña's effects. During La Niña, colder winters typically strike Central and Western Europe, including Germany, France, and the United Kingdom. Energy demand rises, roads become icy, and crop growth becomes difficult. Southern European regions like Spain and Italy may see reduced rainfall, exacerbating the drought issues that have plagued the region for years. On the other hand, Scandinavia and parts of Eastern Europe may experience increased snowfall and lower temperatures. Globally, the interconnected impacts of La Niña continue. The Panama Canal relies on stable rainfall to operate. During the last El Niño Southern Oscillation (ENSO) cycle, the canal experienced record delays. Now, with rainfall expected to decrease again, global shipping could be disrupted, affecting supply chains from Asia to the Americas. Agricultural prices, insurance premiums, tourism flows, and even political stability in vulnerable regions could be affected by La Niña's next move. Because, without a doubt, this is not just about the weather. It's about the world economy, food security, and human survival. And the most adaptable regions will be those that understand its patterns before disaster strikes. In the next chapter, we will dive deep into the Earth's oceans to see how marine ecosystems, fisheries, and coastlines are being reshaped by La Niña's cold grip. While most eyes are on the storms, droughts, and floods, a quieter crisis is unfolding beneath the surface, affecting every breath we take and every bite we eat. Because La Niña doesn't just reshape the skies, it alters life in the oceans. As colder water rises in the eastern Pacific, the upwelling process intensifies. This brings nutrient-rich, deep water to the surface, promoting a surge in phytoplankton, the microscopic plants that form the base of the entire marine food web. In the short term, this might seem like a good thing. Fisheries in places like Peru and Ecuador might boom for a while, but the balance is fragile, because La Niña also disrupts the natural flow of ocean currents, causing some species to migrate unexpectedly or even disappear. Sight. -1 fish that once fed coastal economies may swim hundreds of miles away. Other creatures might die if the water temperature drops too cold, too fast, and the chain reaction is immense. During the 2010 to 2011 La Niña event, sardine and anchovy populations off the coast of Chile plummeted, disrupting entire communities. Now, in 2026, similar signals are emerging. Mass strandings, altered migration routes, and early signs of stress in Pacific and Indian Ocean ecosystems all indicate that marine ecosystems are facing a severe challenge. And then there are the corals. Unlike El Niño, which brings devastating thermal stress, La Niña can bring temperature fluctuations. Bleaching on some coral reefs may be temporarily relieved, but other areas, especially in the Western Pacific, may face cold shocks, high salinity, and even reduced light levels due to increased rainfall and sediment runoff. According to a 2024 report by the Australian Institute of Marine Science, reefs around Papua New Guinea and the Solomon Islands are already showing signs of stress-induced bleaching, even in cooler waters. La Niña's impact doesn't stop there. It also strengthens the transport of dust from Africa to the Americas. This dust drifts across the Atlantic and settles over the Amazon rainforest, acting as both a fertilizer and a threat. If imbalanced, this dust can disrupt cloud formation, block solar radiation, and trigger complex feedback loops in the local climate. Even the rainforest can feel La Niña's breath. The ecosystems of the land and sea are not just responding to the Earth's new rhythm. Under the weight of change, they either adapt, struggle, or collapse. The consequences will extend far beyond the coastlines. However, climate change is making La Niña more complex and unpredictable. Since the Industrial Revolution, human activities have released over 1.5 trillion tons of carbon dioxide into the atmosphere, causing the global surface temperature to rise by 1.2 degrees Celsius. The oceans have absorbed over 90% of this excess heat. This is important because the engine of the El Niño Southern Oscillation, UNSO, is fueled by ocean heat. As the heat rises, its engine becomes more powerful and unstable. Several recent studies, including a landmark paper published in the journal Nature Climate Change in 2023, reveal a grim reality. By the end of this century, the frequency of extreme El Niño and La Niña events could double. Climate fluctuations that once occurred once in a generation may soon become a once-a-decade, or even a multi-year event. Yet, frequency is not the only concern. The intensity of these climate phenomena is also increasing. Researchers at the University of Hawaii have found that in recent decades, La Niña events have been cooling faster and lasting longer, especially after a strong El Niño. This phenomenon is known as the UNSO rebound effect, and in 2026, we are witnessing it firsthand. Furthermore, climate change has caused the center of UNSO activity to shift westward across the Pacific. This may seem like a technical geographical change, but its implications are profound. It means that more densely populated regions like Southeast Asia, the Philippines, and Eastern India will be closer to the center of UNSO's most destructive impacts. More people and infrastructure will be exposed to its threat. Against the backdrop of global warming, the Earth's atmosphere holds more moisture. This change is making storms more intense, wetter, and less predictable. Even the traditional warning signs of the El Niño Southern Oscillation, UNSO, like trade wind anomalies and sea surface temperature readings, are now increasingly difficult to interpret. The UNSO system itself is changing. This raises a crucial yet unanswered question in climate science today. Is the UNSO cycle still a natural cycle? Or has it become a hybrid cycle, influenced, amplified, distorted, and accelerated by human activities? Scientists do not yet have a complete answer, but the trends are clear and are intensifying. Climate extremes continue to escalate, and the feedback loops between the oceans, clouds, forests, and glaciers are accelerating. What was once a climate phenomenon like a regularly swinging pendulum has now become more like a destructive wrecking ball. The longer we wait to adapt to climate change, the harder it will be to keep up with the climate's next swing. In the final chapter, we will delve into a series of questions. Can we do anything? What can we learn? How can we prepare? And what is the Earth trying to teach us before it's too late? While we cannot stop the emergence of La Niña, calm the waves of the Pacific, or make the trade winds change direction, what we can do is be fully prepared. The first and most powerful tool we have is information. Today, a global network of satellites, ocean monitoring stations, and climate models continuously track sea temperature, wind direction changes, and cloud patterns. With this network, we can now detect the early signs of an El Niño Southern Oscillation, UNSO, event months in advance. This warning system has already played a huge role and saved countless lives. Looking back at 1997, the El Niño event caught the world off guard. By 2015, however, thanks to more accurate forecasts, dozens of countries were prepared in advance, greatly reducing losses and casualties. However, accurate prediction is only half the battle. We also need to build resilient infrastructure. In regions like Bangladesh, low-cost cyclone shelters and elevated homes have significantly reduced deaths from storm surges. In Peru, early planting strategies and crop diversification initiatives are helping farmers withstand the rainfall fluctuations caused by UNSO. In cities like Miami and Houston in the United States, flood defenses are being strengthened and early evacuation plans expanded. These are not concepts for the future. They are effective, real-world solutions. Beyond infrastructure, the power of humanity cannot be overlooked. Education, awareness, and local adaptation actions are equally important. In 2022, a La Niña event triggered a deadly drought in the Horn of Africa. In responding to this disaster, it wasn't just aid agencies that played a key role. Local communities actively built reservoirs, planted crops, and shared traditional knowledge. Climate resilience does not just depend on high-tech satellites or global agreements. It's about what happens in a village, a city, a coast. because the ENSO phenomenon will persist and La Nina will come again. But we don't have to be caught off guard anymore. The more we understand these natural rhythms, the more chance we have to work with them, not against them. The more we listen to what the Earth is trying to tell us, the better prepared we can be for what comes next. La Nina is not a villain, nor is it a mistake. It is part of a living planet, a natural phenomenon that is constantly changing, pulsing, and adapting. But things are different now. The climate cycles are becoming faster, the impacts more intense, and the signals more obvious, as if the Earth is urgently warning us. Pay attention. I am changing. Are you ready? This is not just about the changes in the Pacific, the rainfall in Asia, or the drought in Africa. It is about the fragile connection between all of us, from the farmer in Peru to the family in Florida, to the fisherman in the Philippines. The weather we experience is shaped by these unseen forces, and understanding these forces is the key to gaining control, to adapting to climate change, and perhaps to our survival. If you have watched this far, you are already ahead of most people. You are listening attentively, learning actively, and there is still much more to discover. So please, stay curious, and whatever you do, don't miss what happens next. Alright, that's all for today's video. If you like this video, please give it a thumbs up. We'll see you next time.